Okay, when seeing the word function, this might be the first time you've seen the word function in math.
No.
Okay, have you heard it before?
Oh, in math.
Okay, function is notated as f of x.
Oh, yeah.
That's how I read that, f of x. Okay? In your math career, you're going to learn about a bunch of different functions. Linear, quadratic, polynomial, a bunch of different functions. Exponential, okay? In this class, we're going to learn about linear. What does a linear function look like? It's in the word. It looks like a line, okay? And what that means is we're going to have x plus some number. I'm just going to say 2.
It's 2.
Okay? That's what a linear function would look like. It's x plus some number. Okay? What I want you to understand is f of x, that also means the same thing as y. So these two equations mean the same thing. F of x is also meant as y. Y also stands for f of x. And f of x, what does f of x stand for? Function, right? Function. Okay? So, let's start looking at some relations. A relation is the function itself. Okay? Ordered pair, what is an ordered pair written as? X and y. What comes first? X. Okay? So x is what we're plugging into the function or what we're putting into something. Okay? So underline all your x values here. All of our x values. What do you notice?
No high five.
Do any of them repeat? Which one? 54 repeats. Okay. 56 also repeats. Let's look at 54 first. Shh. Let's look at 54 first. 54 the first time had 112. So what should it get the second time? It should get 112, but does it? No. So this means it is not a function. Okay. Was there another example? 56. Okay. The first time I plugged in 56, I got 130. Should I have gotten that the second time?
No.
Yes, but did I?
No.
No. Okay, so that first example is not a function. Okay, each x value should only have one y value. So looking at B, similar, but it's written in a table form this time. Still only look at your x's. Okay, here are all my x's. Do we have any that repeat themselves?
No.
6.
That's on the different.
You got to look at the x values. So we only want to look at these x values. We don't care about the y's right now.
None of them were.
Do any of them repeat? No. So this is a function.
Yay.
Okay, no x values repeat that we have to worry about. Okay? Any questions so far? So what values do we care about? The x or the top, okay? So always find your x values and look at those. Okay? Flip your paper over. Go ahead and try those two examples. What values do I care about? X. Is the x the first or the second one? First. Do I have, what do I ask myself next?
Do you have any repeating?
Do I have any that are repeating?
No.
No. So is this a function?
Yes.
Yes. Each x only has one y value. Okay? Since it's in the table form, what values do we care about? X, which are on the top. Okay? Now what do I look for? Any that are repeating. Do we have any? 3. The first time we get 5. What should I get the second time? 5. But do we? No. So is this a function? No. If I did get 5 right here, would it be a function? Yes. Okay. Any questions so far with ordered pairs and tables? Let's look at what it looks like for a graph. What I want you to do, think to yourself, is this a function or not, just by looking at the graph? When we had tables and ordered pairs, what value did we care about? X. Where's X on a graph? Show me with your arms. Horizontal or vertical? The x-axis, where is it? It is horizontal, okay? Our x-axis is right here, okay? So we care about our x values. How many solutions should each x value have? 1, okay? We pointed out here that 7, if you look up, it has 2, right? So is that a function? No, because it should only have 1, okay? If I wrote this as an ordered pair, how would I write this as an ordered pair? 7, 2. Okay, how would I write this one? 7, 5. So as an ordered pair, we can see that 7 has 2 different solutions. So that breaks it to be a function. Okay? Everyone, hold up your pencil vertically.
Which way is vertically?
This way.
Up and down.
This is horizontal, this is vertical. Okay? Put it on your graph. Put it on your graph. Put it on your graph. Okay? This is called the vertical line test. Okay? If you can't visually just look at it, you can use your pencil or a piece of paper or your calculator or anything. Okay? Start at the left and slide your paper across. Here, how many values do I hit? 1. What about here?
10.
Here?
4.
Here?
5.
What about here?
6.
I hit 2 here.
What?
Okay, I have 2 spots here.
Yeah.
So that breaks it. Okay, if I hit 2 spots or more than 2, that breaks it. Okay, so this is not a function. So you can use the vertical line test to help you. Okay? Questions?
No.
Okay, I want to talk about an example that is not in your notes. See on your worksheet. Okay? Here, I want you to draw this picture.
This look like
Just draw the picture.
Those look like chromosomes.
Okay? Draw this picture.
Dawson, that's a little too
does it
hard.
matter where we draw it?
Nope.
Shut up.
Answer that question. Okay. I just picked random numbers. There's no rhyme or wrong to where I got those numbers from. Okay? Domain and range. Now, we're not specifically learning about domain and range. Okay, but are there any guesses as to what domain and range is?
Domain is like the area, and then range is like the
It deals with the x's and the y's. Which one's the x?
domain.
The domain is the x. Okay, so I want everyone to put an x above domain. Range is the y. Good, that's all I want you to know. Domain is x, range is y. Okay, how many x values, how many y values can each x have to be a function? It can only have 1. Okay, so to signify that, do you agree that this would be a function? I just drew random lines. Does every x here have 1 y value?
Yes.
Yes. What if I added in, I'm going to erase that line. What if I added in
You can't do that.
that line?
No.
Hang on. Does each x still only have 1 y value?
No. Wait, what'd you say?
Does each x only have 1 y value?
Yeah.
Yeah, so does it matter if 2 x's share the same y value?
No.
No, it doesn't matter. Okay? What would happen if I drew in this? Why is that not a function? Because 3 goes to 2 different y values. Okay? So they can also use this mapping to show relations. Okay? Is there any questions with this mapping? No? Okay, about today. We're going to talk about finding function values. Okay? So on here, it gives us a function, and then it asks us what f of 7 is. Any ideas how to find f of 7?
Substitute and multiply.
Bingo! Substitute the 7. Okay, so what this is going to look like, show your work, f of 7 equals. Here, in the equation had f of x, and it had an x in the equation. Since we have f of 7, we're going to substitute 7 in for that x. So now, when you substitute, is the x still in there? So if I substituted Kellen in for Braylon in a basketball game, is Braylon still in the game?
No.
No. So x is out. Okay? So how do I solve this then? What do I do first? Multiply, right? 6 times 7. 42. And then we have plus 5, which is 47. So 47 is the y value for 7. That's its function value. So every time I plug in 7, should I still get 47?
Yep.
Yes. Okay? What about f of negative 4?
10.
What about f of negative 4?
So,
How do I find f of negative 4?
You plug in with 4.
I plug it in for x. Someone tell me what I need to write.
6 with the quotation.
Negative
4 and then the other one. And then plus 5.
Good. We're still using the same function, but now I'm plugging in negative 4. What do I do first? Negative 24 plus 5 equals negative 19. Okay. So every time I plug in negative 4, what should I get? Negative 19. Okay. Go ahead. We had more.
Oh yeah.
Okay. Never mind.